All right, in this example, we're going to use a similar technique as in example 3, except we're going to be using variables instead of numbers. And so we're going to rewrite this equation in terms of sign. So sine of y equals x. So we're going to draw a triangle. If we make y our angle, then sine we know is opposite over hypotenuse. Well, this is x over 1. So we can use Pythagorean theorem to solve for our cosine. So x squared plus adjacent squared equals 1 squared. So a squared equals 1 minus x squared. And then we take the square root. It's plus and minus the square root of 1 minus x squared. Well, since it says that y is between 0 and pi over 2, we can just use the positive version. And we know that adjacent is 1 minus x squared. And so cosine of y would be the square root of 1 minus x squared over 1. So just square root of 1 minus x squared. All right, in example B, we're going to do the same thing. We're going to rewrite it as secant. So secant of y equals x. So I'm going to draw my triangle. I know this is y, this is a right angle. Secant is hypotenuse over adjacent. So x is my hypotenuse, 1 is my adjacent. So I can solve for the opposite. Let's label opposite w, because O looks too much like a 0. I did that earlier in another video. So 1 squared plus w squared equals x squared. So w squared equals x squared minus 1. So w is the square root of x squared minus 1. And we're going to use the same restrictions that y is between 0 and pi over 2, so it's going to be positive. So to find tangent of y, we're going to do opposite, which is the square root of x squared minus 1 over 1. So that would be the value of tangent.